I will find it.
When you can share your screen then, right?
Mm-hmm.
Okay, you can share your screen. So need second derivative and probability, probability distribution, normal distribution.
Mm-hmm. So I wanted to go learn about simple harmonic motion.
Math, physics, right?
Mm-hmm.
Okay, yeah, no problem. Simple harmonic motion is part of vibration, okay? And also it is the simplest vibration that can be described by trigonometry function. That is what called a simple harmonic motion. In other words, did your teacher show you any phenomena of this simple harmonic motion?
No, I don't think so.
Right. Yeah. This is yeah. Can we start from this? Can we talk about this formula first? Can you see? This is x equal to 6 sine pi t plus pi over 6. Is this part of your mathematics or is part of physics?
This is part of mathematics.
That's right. Yeah, it's very interesting. They introduced this idea in math first. Can we? I know now. Can we just use? Can we just? We just use this example. See, given this formula, determine the initial displacement and the displacement after 1 second, and at what time displacement is a particle stationary for first time. Yeah. How much do you know about this? Can we just stop your sign? I know the topic is now. We can use whiteboard. So basically, let's just perhaps we can talk about a simplest of oscillation, right? I draw a diagram this time. If we consider a spring here, if I use a spring to make this harmonic motion, so this is a spring, right? Physically, we just connect them to the object, okay? And this object, and if this is 0, is can we say the position of this system, of this position of this mass can be described by x, or their displacement, right? And 0 is also the balance equation, a balance position. You see, at this moment, the force equal to 0, and the spring has no force. Okay. However, if you push this object, make this spring longer by external force, and the force will show up. Okay. And as a result, once you release this object, the object will oscillate. Can you see?
Yeah.
First, they return to the equilibrium position because they still have velocity or kinetic energy. They will continue to move to the other side. Okay. And this side is equal. Can you see? Equal. This is so this, if I call this amplitude, and that would be the negative amplitude, right?
Yeah.
So you can imagine if you just using a time, if I just draw the time this way, so this is the time, if I use this as a time axis, right? And this horizontal is x-axis. So can you imagine what kind of curve can we obtain? So this is negative a, and this is a positive a. Can you see? Maybe so if you divide this into 4, 1, 2, 3, 4. Can you see? Can we follow this displacement x. The x will, if it's originally at x, so x were first. The first, let's just use this color. So first return to the equilibrium, to the equilibrium position, all right?
Mhm.
And then what would happen? You just continue move to an extreme, to the negative a, right?
Mhm.
And then return, change direction and go to the balance position. And it just continue periodically. Can you see that?
Yeah.
So I just draw the one period. We just draw one period. So this is a diagram in the vertical position, right?
Mhm.
Of course, we can rotate that into the horizontal. You see, we rotated everything by 90 degrees. You see, this is
Yeah.
x, this is 0, this is time axis, and this is a maximum displacement called amplitude. This is negative a, right?
Mhm.
And that is will be the diagram, the graph we can obtain. 1, 2, 3, 4. So in this way, we can use this. We can describe this position at any moment by a trigonometry function. Which one should we use in this case? In this particular example, which function? How do we got the formula for displacement?
It'll be a cos function because it doesn't
Yes,
stop.
yes.
up
So
here.
exactly the amplitude is a, right? And the cosine, and now we have used. If you use mathematics, we just use b, all right, and multiply the t. Okay. In physics, we prefer to use this notation. We use omega, all right, because omega has a simple relation with a period. Do you remember? If this is a t, is a half t. So the omega here or b here, or in mathematics, they still write this formula in this way. Do you know this formula?
Yes.
T for period is exactly one period. Okay. So that is a special case. But in general, I notice your equation. The xt, this is called. Oh, by the way, this motion is called a simple harmonic motion. Okay. And because this motion is follow the trigonometry function, so in music, when we study music, we just this called harmonic, right? If we use if you study standing wave, so that is that's periodical. Do you remember standing wave? So that is where the harmonic name come from. See, so the harmonica can be made by different trigonometry function. That's why they call it a harmonic function.
Oh.
It is simple because the force in it. Why do we call it simple? They have to learn some little bit of physics. Why do we know it's simple? It is simple because the inelastic force obeys the Hooke's law, right? So that is why we can use the trigonometry function to describe this motion. That is a physical reason we call it simple. If the force is not obey the Hooke's law, can you imagine that? If this is a Hooke's law, do you remember? If we only consider the amplitude, the Hooke's law is a linear function. Can you see? Like this one, can you see? As long as the displacement is not very big, you see, x and the force. However, if you, for the real spring, if the length is getting too long, okay, if getting too long, and they will not obey Hooke's law, so the curve will become something like that, all right, non-linear. So that is why, if you want to use achieve the simple oscillation, you have to make sure the x is smaller than certain value. Can you see? So that is why we call it simple harmonic motion. Just return to the general expression. In general, this expression can be written as a cosine, or you can use a sine as well. It's up to you. And use you use b. Do you see use a b? Multiply t plus some c. Do you remember when you started the modeling? When you use trigonometry function to modeling, you use this notation. All right. But again, in physics, we prefer to write this as this form. A is okay, A for amplitude. And we can use a sine, up to you. We can use a sine, doesn't matter. So we can use omega here, t and plus equals phi, you see. It's Greek letter phi. So each of these have the meaning. So this A, so A is called amplitude, okay? And omega, what is omega? Is called angular frequency. Angular. Have you heard of angular frequency in physics?
No.
Oh, you studied wave. You have studied wave, but you haven't studied angular frequency. Interesting. Anyway, so the whole thing, anything, can we these things called the phase, okay? Because I noticed that sometimes they will use this terminology in physics. And this phi here is called initial phase. Initial phase. Initial phase. That's it. That's some related idea, okay? You can either use mathematical form. For example, if I remember in your example, the example is something like that. You got some number here, right? And you got the another number here, and you got the t and multiply the half. So say angle. Can you see that?
Yeah.
This looks like the example you are dealing with, right? Okay, can we return to example to see what the question they ask? I stop my side first. Yes, okay. Can we start from question 3? This or we can start question 2. They got the same. Can you see? They get pi. Now, could you tell me in this case what is period? Just using the knowledge we have. Can you see the first part, the question 2, the first sentence at the end it said x equal to 6 sine. In this formula, from this formula, can you tell me what is period for this oscillation or simple harmonic motion? Using that b equal to 2 pi over t.
Is it just pi?
Pi is b or omega. How do we convert that number into? How do we obtain how do we determine the period based on pi, which is angular moment frequency here?
We know that pi equals 2 pi over period.
Yes. So what is t?
So t is 2 pi divided by pi. So it's equal to 2.
2. Yeah. Yeah. That's yeah. That's it. That's if this international system is just 2 seconds. All right. Right. So given this position at any time, can you answer each of these questions A, B, C, D from F to F? How do we determine the initial displacement?
You substitute 0 for t.
Yes, that's correct. How do we determine the after 1 second?
T equals 1.
Yes, as simple as that. Yes. How about the B?
Do you have to do the derivative of it and then figure out 0?
Now, if depending they ask, See, if they just ask a displacement, we can use the formula directly because X represents the displacement.
Mhm.
Do you remember? Can you follow me? X, the function represent the displacement. Okay. So for the first two questions, you don't have to derivative because they are asking for the, at what time? Can you read the question B?
At what time and displacement is the particle stationary for the first time?
Yes. How can we? Oh, that's right.
Mhm.
Stationary, you have used velocity. You are right. Yes. To answer the B, you have to determine what is the velocity formula first.
Mhm.
Can you write it down? Can you write anything on your side? If you can't, we just use a whiteboard. You're asking.
Don't think I can.
We just see what is the asking question before we go to whiteboard. The third, can we read C? What is question C?
At what time and displacement is the speed of the particle at its maximum value for the first time?
Okay, how about D? Determine initial acceleration. How about E?
Determine the acceleration at the origin and at the end of each motion.
Well, all of these questions are related to the formula for the velocity and acceleration. Can we go to whiteboard? Can we go to whiteboard to 6 pi? Hopefully I can remember these numbers. Or if I can't, you can tell me. So this particular question 1 or 2, rather, is xt, right? Right down over here. Xt equal to, can you write formula for that?
Yeah.
Yes. To answer the question B, you need to find where the formula for velocity first. How can we do that?
You have to derive it first.
Yeah, you have to find the derivative. So how do we find this one? So for the question B, how can we work out velocity in the first place before we discuss whether when the velocity is 0?
Dx over dt.
Yeah. Can you work it out? Dx dt, yes, that is the definition. Yep, that's right. You can put a pi in front. That looks better. Yep. So you can find the time for the first time that the velocity is stationary, right? So stationary is a velocity equal to 0. So what can you do? Little bit of trigonometry function. Yeah. Yeah, you need x v equal to 0. So you solve for the time, right? Okay. Any equation we can draw from this condition?
We know that cos equals 0 when this is equal to pi, I think.
No, pi is not 0. It's think about it. It's a special.
Oh, it's pi over 2.
Yeah, half pi, right? It's always a multiple of half pi. Yeah. What is the general formula, by the way? Can you write this as a general formula? Yeah, these are two of them. Okay. Now k must be an odd number, right? How can we rewrite this formula? Make sure k is
k plus 1.
Okay. 2k plus 1, do you agree? You forget the 2 here. Do you have to use 2?
Mhm.
Because that will give you 1. Can you see? If you
Yeah.
if that will give the 1 and the 3 and so on. Can you see? So that's notation. You will know how to use that. So if you rewrite this number as you see, if you have how to find the so 2k plus 1. Okay. So that will equal to 1 when k equal to 0, right?
Yeah.
Equal to 3, k equal to 1, and so on. So that is what we call the general formula. All right. Now, so of course, in this case, which k should we use to answer the question B? Which k should we use? They're looking for the first time, right? Can you read the original question? Are they looking for the
Yeah, they're looking for the first time, so it would be pi 2.
So which k? Which number should for k?
0.
Yep, that's right. One third, yeah. That's it.
Yeah.
Yeah. Do you want to try out any other questions? See, you can read, you can see that, right? You can see from your side. What is C?
At what time and displacement is the speed of the particle at its maximum value for the first time?
Displacement.
Is the speed at its
the speed, not displacement, the speed, yeah.
Yeah.
The speed, yeah, that is the same formula for velocity.
Do we have to figure out when it equals 6?
What is the question? I forgot. What is the question? I didn't catch that.
When is the speed of the particle at its maximum value for the first time?
Max value of speed, right? Okay. Okay, that's right. You can use the same formula. So what is the max value for velocity from this formula you derived? So this is the formula you derived, right? So this is velocity formula you derived. How can we work out the maximum? What is maximum? Do we have use calculus or you just use a trigonometry property?
I think it's when it's equal to 0.
No, the maximum speed is determined by the amplitude. Can you see? Let me go to the diagram here. Can you see? No matter what, so this is for x, but for if you just redraw this diagram for the velocity, we just use the same diagram. Can you see? Velocity will be the derivative. Oh, this is that is a cosine. This is cosine. Now, in general, you have to, can we just rewrite this velocity? Can we just rewrite velocity as this? Can you see? That's V null is the magnitude. Can you see?
Yeah.
You got a cosine. In this case, is a pi t plus pi over 6. All right. Now, compare with your formula. What is V null?
6 pi.
Yes, so 6 pi.
So does that mean that's the maximum value?
That is max. Yeah, that's maximum value for the velocity. But they want to know the time, right? In other words, how can we determine given that is maximum? If the question is this, okay, if V is exactly equal to V null, then the question is what is the t? That is the question. Do you agree? So given this one, what is the t? It is a bit of trigonometry here. If V must equal to V null, what would be the cosine pi t plus pi over 6. Yes, that's right. So you should be able to derive the formula. Yeah, cosine must be equal to 1. Okay, according to trigonometry, how many possibility, how many value for t?
It's just one because it says for the first time.
For the first time, well, okay, you found the smallest value for that angle is pi. Okay. That's right. Okay, that's it. How about a second question? D.
Determine the initial acceleration.
Okay, acceleration. Do we have formula for acceleration now?
You have to do it.
You have to derive it. You have to work it out. Yes, you have to derive the formula for acceleration. Yes. Pi square. Yes, that's right. Okay, you turn to what is the question thereafter?
They want to find the initial acceleration. So
initial acceleration. Okay. Just net equal to 0. Yeah, t equal to 0. Yeah. 30 degree, simple, half, right? Sine 30 degrees half, right? That's it. Any other question? E or F?
E is determine the acceleration at the origin and then at the end of each motion.
All right.
Does end of each motion mean pi? Each pi?
At each motion, at each period, is that? What is the
Oh, it says at the end of each motion. So would that mean period?
Presumably, yes, at each motion, at each periodic motion, what is thereafter, right? So what you do is just pick up the integer of period. Okay. So you are looking for do you have to know the period now?
Yes.
That's right.
We
That's
know
right.
the period,
Yeah.
which is 2.
So that is a return to the first question. How do we determine the period by this formula? Can we go to this page? Can you write the X formula here? Can you write for X formula to identify the period? Did we say 2 seconds or something like that? Half second?
Yeah.
2 seconds. Yeah. Okay. So that gives you the time, right? So at each period, you can substitute this as t. Yeah, we know the formula for the acceleration sine. Yes. Perhaps you just use a capital T here for period, all right?
Mhm. And then you just keep adding.
That's right. It's just single value, right?
Mhm.
And 2 pi and 6 pi. Yeah, it's the same as half. Okay, it's the same because 2 pi is a period of the trigonometry function. So you just you can simplify from here, right? You can simplify just equal to 6 pi square sine and pi over 6. Can you see? Because this is a periodic function. You see, it's periodic function.
Yeah.
You don't have to add them up because this is exactly the period.
So it would be the constant acceleration. Which
Yeah,
is negative 6 pi squared.
so at each end of period, the constants have a proper have the specific value which is identical, independent. It doesn't matter which period. It's also repeat this value at each period. Can we just simplify this as half? Can you see this is half, right? This is just half. So that's just 3 pi squared. So that would be the value. Any EF? Do you have other additional question?
No, but there are other questions.
Okay, you can pick up question. You can copy the formula. We can solve on the whiteboard, right? This is just part of the application of calculus, right? Which question is question 5, 6?
Question 4.
Question 4. Okay, question 4. Yeah, given the velocity this time. So what is the question?
It says determine the period.
Again, yes.
Amplitude of the motion.
That's right. Perhaps you can find the magnitude first because you can just copy them later, right? What is amplitude from this formula?
I think first we have to make it into x, right?
Good idea. Yeah, good idea. Yeah, so that's why you need to find the period. That's right. You need to find the period first. Yes.
So amplitude equals 3.
Yeah. Capital T, you can use capital T. With pi, yes. Double check that. So B this time equal to 2, right? And equal to 2 pi over T. Yes, you're right. Then that is the result. Yes. Okay, next question.
It says determine the position after 5 seconds if the initial displacement was x equals -3.
Yes. You can use which form? You can use a position formula, or you can use yeah. This is, you can call the position or displacement from the origin, from the equilibrium position. Okay.
And that I think you just put into the calculator.
Yeah. Do you need to find the T or?
They give you T.
They give you T.
5
right?
seconds.
Okay, 5 seconds. Yeah, that is simple. Any other question?
No.
No. Can we look at your textbook to see if any other question you want to ask? Yeah, to solve this type of question, you only need to know how to determine the acceleration and the velocity from the given the displacement formula. Particle move with a simple harmonic motion. Do you want to pick up another question? Or not necessarily simple harmonic. Oh, they're all simple harmonic motion. Stiffness constant. Do you know the stiffness constant? Or spring constant?
No.
Yeah, that's Hooke's law. Can we? In that case, can we try? Can you try the number 6? Because I mentioned. Do you remember? I mentioned Hooke's law at the beginning. I'll go to whiteboard. Let's go. Sorry, let's go to the whiteboard. Yeah. Okay. Can you draw? Can you? So what is a scenario? They have the spring vertically or horizontally placed?
Vertically.
Vertically. Okay. You can draw the diagram. So the vertically like this, right? And they have the stiffness constants or inelastic constant. So the mass. So a little bit of physics here. How can we work out the K, the stiffness constant, from the formula for displacement or velocity, right? So any other condition?
We have the mass, which is 5 kilograms.
Yeah, 5K. So that is a condition.
Which is 0.28.
So we got the mass equal to 5 kilogram. Okay. Any other condition? Period is given, right? Period is the second. How many seconds? 5 as well. All the 5 seconds. Amplitude is given. All right. That's presumably the meters, right? Okay. This is physics, not mathematics. How can we work out this stiffness constant? Do you know the related formula for this question?
No.
No. So basically, the inelastic for the acceleration. So for the simple harmonic motion. So basically for simple harmonic motion, okay, the acceleration is equal to this is a constant, okay, omega square and multiply displacement. So that is another, this is, you can derive this formula by yourself. That is another way to define the simple harmonic motion if acceleration can be written as a product x and multiply omega. So what is omega? Omega by definition is equal to 2 pi t, all right? So that's why in physics, I prefer to use omega. In other words, you can see this omega in a harmonic motion over here. Can you assume, use a sine omega t, all right?
Yeah.
So what is the relation between omega and the constant? Well, you have used, we have used Newton's law, can you see? Can we use Newton's second law, mass multiply acceleration, right? In this case, it's determined by the force of the Hooke's law, you see? So if you divide this n, what can divide n? So what can we obtain? K over m, right?
Yeah.
Okay, now if you compare with these two formulas, you should be able to find the formula you want. This is A after all, do you agree? Okay, this is related for, they are the related formula. Yes, there's a simple relation here. Can we simplify this question? Can we cancel negative sign and x?
Oh.
Yes, that is it. That's it. In general, if you study physics, and you can simply conclude that omega is equal to square root, can you see? K over m, because just get by comparing equation 1 and equation 2.
So now we can figure out K.
Yep, K is stiffness constants. So this is the Hooke's law. I just remind you, okay? So this come from the this is from the MA equal to force, and the force in our case is determined by Hooke's law. Can you see? So this K is called the stiffness or elastic constant. So this is Hooke's law. Hooke's law. Okay. Yeah, very brief. I know your textbook very briefly. You didn't speak learn much about the Hooke's law.
Yeah, I don't think so.
Okay. Okay, does that make sense now? Yeah. Good. Any other question?
No, not really.
No. Okay. Maybe you can. Can you share your? Can make sure? Can you share your textbook to? This is question 6, right? Oh, if you understand the simple harmonic motion, we can discuss other issues. 7, for horizontal spin. So there's sometimes horizontal, sometimes vertical, right? And 8, children standing unmoving. Sprung. Yeah, we can go to higher. So which of the following relation does not represent a simple? Yeah, can you just this is a physics question, right? Can you go to 14? Can you answer the question 14? Which does not?
Question 14.
Yeah, which does not? That is an opposite question. Or you can pick out which does first. Which A represent, yeah, that's a typical simple harmonic motion. So that is not answer. How about B?
A is typical simple harmonic?
Well, if you assume X obeys that condition, yes, you can. You can assume that X provided X equal to negative. You see, if B is a simple harmonic motion, we can only assume that cosine pi t equal to negative X. That's all. How about C?
I think it is.
Oh, what is criterion? You don't think, you use the criterion. Which criteria you make it to?
This is velocity squared.
Yeah.
It's like a quadratic. It would be a quadratic also.
Well, let's just discuss that one. Can we see? V square equal to 4x squared minus c squared. Can we just stop your sign? 4x minus c squared, if I can remember that. It's just different way to ask the question. So they ask you. I just pick up the color. Is that the second derivative? Sorry, v squared, right? V squared. Can you write the relation they provide? X squared take. Can you write the equation they're given? It looks like the harmonic motion, but not very obvious. Oh, they got the c squared x cubed. Do you have x to the power 3? Are you sure?
Oh no, it's 3 to the power.
No, it's just 3 square. Yeah, it looks like the harmonic motion because if you have studied physics, this looks like the energy conservation law, right? And but how can you prove that? That is the issue. So the criteria is that the second derivative is equal to a constant, okay? A constant multiply x. Now, how can we prove that? So we got square equal to 4x squared take 3. Now, how can you prove that? Oh, this is c squared. Probably not. I think it's probably not. But if you can prove that, how can you prove that? So the criterion is here. If you can derive the formula like this, then they are harmonic. Otherwise, they are not. Oh, you square root them?
It's not 4, it's 2.
Oh, this is a Frischmann. This is again Frischmann's. It's Frischmann's string. You cannot square root like this. If you got a square root on both sides, you got 2 square root. This can you see? You cannot get this one. This is a Frischmann's string. Frischmann's string. You know the name? Did I mention this before? Frischmann's string. In American, Frischmann, the first year student in uni is called the Frischmann. So they have this dream to simplify. You can only get this one. Unfortunately, this is wrong. Yes. Very unlikely. How can you? Yeah, you derive. Yeah, you got first derivative. Yes. Yeah. With respect to the time. Yeah, I think it's not, okay? It's not harmonic, but put another way, if the sign, can you say, if I put another thing, if we change the sign, they could be a simple harmonic, can you see? If I twist this question, if I just write this v squared equal to 3 squared minus x squared, perhaps in this way, I should be able to get, we can argue this is a harmonic motion, simple harmonic motion. Do you know why? Because if I just do some replacement, can this v squared here? can we put this 4x squared here? That will equal to 4 multiplied 9. Okay, 36, right? Can you see this equation? Now, if you compare with this formula, the kinetic energy, okay, plus potential energy. Do you know the potential energy for the elastic spring? No?
No, I don't remember it.
Yeah, okay. I just say if you twist this question, then we can prove this is harmonic motion, because that will tell us there is a kinetic energy plus potential energy equal to a constant. Okay. And this condition also must be satisfied. But of course, in your case, you got a negative here, so we cannot achieve that. We cannot use this argument. All right. So it's not. Okay. So this is not. So this is not simple harmonic motion. All right.
Yeah.
Okay. You'll be fine. You should be fine. Simple harmonic motion. You should be able to tackle that.
Yeah.
Is this part of your coming exam?
Yes, I'm pretty sure it is.
Wow, you have learned a lot. Yes, because see, normally we need to teach. We still need to study that this background from physics. Okay, but unfortunately you don't. All right, we'll see you next time.
Yeah, Friday.
Our Friday, and stop this. Okay, goodbye.